guys, so today we're going to take what we used about the principle of zero products and use it to solve polynomial equations. Let's get started. So this slide is just here to remind you what the principle of zero products is. It basically says that for any real numbers a and b, if a times b equals 0, then either a equals 0 or b equals 0, right? If you have two numbers, you're multiplying them together, and the product is 0, one of those numbers has to be 0. If you're not quite sure about this still, go back and watch the introduction video to the principle of zero products. So let's take this principle of zero products and apply it to solve polynomial equations. So in order to solve polynomial equations using the principle of zero products, you're going to do three things. You're going to be given some sort of polynomial equation, and the first thing you want to do is set that equation equal to 0. The second thing you're going to want to do is factor. So after you set your equation equal to 0, you'll look for a GCF, you'll count the number of terms, and you'll determine what factoring strategy you're going to use, whether that's factor by grouping, AC method, difference of squares, whatever method you need to use in order to factor that polynomial. And the last thing you're going to do is use the principle of zero products to solve it. And we'll talk about that in our example that you'll see on our next slide. So here's our first example. It says solve, and it gives you this lovely polynomial equation, x squared minus 7x equals negative 10. And if you remember from the previous slide, the first step when you're doing these is to set your equation equal to 0. Well, right now, our equation is set equal to negative 10, so we need to move this negative 10 over to the other side so that we're left with 0. And how do we do that? Well, we use inverse operations. So I'm going to add 10 to both sides, right? That will get this to 0 out. So that leaves me with x squared minus 7x plus 10 equals 0. All right, so I've done my first step now. I've set my equation equal to 0. The second step is to factor. So when I'm factoring, I know the first thing that I do is I look for an overall GCF. Here our polynomial is x squared minus 7x plus 10. There is no overall GCF. So now the second thing I need to do is count the number of terms to determine which factoring method I'm going to use. So I have 1, 2, 3 terms, which means I'm going to be using the AC method. Okay. So let me come over here and I'll draw my table. Multiply on one side, add on the other. I do this every time I use the AC method, you guys. Okay. What am I multiplying? I'm multiplying a times c. Here my a is that invisible one, right? So my a is 1. And my c is positive 10. And you know what I'm going to do? I'm going to make some more space here. So I write this a little bit smaller. My a is 1, my c is 10, which gives me 10. Okay, and so I need factors of 10 that add to b, and my b here is negative 7. Okay, so notice, you guys, I want factors of a positive that add to a negative. Okay, the only way that I can have two numbers that multiply together to give me a positive, but that add together to give me a negative, take a minute and think about it, is if both of my factors are negative. So let's just break this down. Let's write all the factors of 10, right? We have 1 and 10. I always start at 1. Then we have 2 and 5. And that's actually it, okay? So notice if I add 1 plus 10, that gives me 11, which is clearly not negative 7. And if I add 2 plus 5, well, that gives me positive 7, but not negative 7. So I posed this question to you just a few seconds ago. What is the only way that I can multiply to get a positive, but add to get a negative? Well, both my factors would have to be negative, right? So I could take these factors that I found up here, and instead of them both being positive, I'm going to make them both negative. Negative 1 times negative 10 still gives me that positive 10, okay? And now let's change my 2 and my 5 from positive 2 and positive 5 to negative 2 and negative 5. Negative 2 times negative 10 still gives me that positive 10, right? So it's really important when you see a negative somewhere, whether it be in your A times C or in your B, that you consider positive and negative factors. And sometimes one of your factors will be negative and one of your factors will be positive. Sometimes they'll both be positive and sometimes they'll both be negative. But you have to always be thinking about that when you see a negative, whether it's in your A times C or your B. Okay? Or both. So be really careful. So now let's see if we can get negative 7. So negative 1 plus negative 10, well, that gives me negative 11. Sorry, I'm squeezing here. Let me rewrite that because that looks just terrible. Okay, so negative 1 plus negative 10, that gives me negative 11. Still squeezing, sorry guys. And negative 2 plus negative 5, haha, victory. I finally got into my negative 7, which is what I wanted, right? I wanted to get to negative 7. So I finally got there. So my two factors are negative 2 and negative 5. Now here's the cool thing about when you have a polynomial where the A coefficient is 1. You can do this really cool shortcut. Instead of using these two factors to replace my B term and then do factor by grouping, I can actually just skip right to this last step and factor, and I can just plug these two values in. So my two factors are going to be x minus 2. I'm just taking the minus 2 here, and the minus 5 I'm just going to put right here. So you can actually just skip right to that last step of the AC method and just plug those in as your actual two factorizations. So x minus 2 times x minus 5, that will indeed give us this polynomial. So we've now factored it. It's in the form of factor times factor. Okay, so we set our equation equal to 0, we factored it, and now we need to solve using the principle of zero products. Well, clearly, I have two factors being multiplied together to equal 0, so I know one of those factors has to be 0. I'm going to erase all this so I have some more room. So either x minus 2 equals 0 or x minus 5 equals 0. So we have two cases here. Okay, so let's look at each of those cases and solve for x. So let's call this x minus 2, let's call this our first case. So maybe x minus 2 equals 0. Well, in that case, x would have to be 2, right? All I did was add 2 to both sides to isolate the x. Okay, well, let's call x minus 5 our second case. Maybe x minus 2 wasn't the factor that equaled 0. Maybe it was x minus 5. So if x minus 5 was the factor that equals 0, then x would have to be 5. All right, and now we've solved for x. So we would write our solution as x equals 2 or 5. All right, both of those answers will make this equation true. And we would, in fact, go back to the original equation, plug those in to check. And you can go do that right now. Here are a few for you guys to try on your own. Make sure you take the time, if you need to go back and rewatch as I do my example if you're having trouble doing this example. And if you have any questions, please feel free to post them in the questions discussion forum. Good luck and have fun. Thanks, guys. Bye-bye.